In 2008, a mid-sized automotive parts manufacturer in Ohio invested $12 million dollars in a custom assembly line. 18 months later, the client changed the product design. The conveyor system was incompatible. The facility had to rebuild at a cost of $9 million dollars. That is the cost of designing a facility before the product is finalized. This week, we zoom out from location models and ask a more fundamental question. What information does a facility planner actually need before drawing a single layout? The answer is product design, process design, and schedule design. In that order. Today's video covers the strategic layer and first of those three, product design. So, strategic planning is defined as the art and science of employing a firm's resources to achieve its business objectives. Before any facility plan is generated, six questions must be answered. What is to be produced? How are the products to be produced? When are the products to be produced? How much of each product will be produced? For how long will the products be produced? And finally, where the products to be produced? Questions 1 through 4 drive product, process, and schedule design. The inputs to facility planner. Questions 5 and 6 feed directly into the location decisions we've been studying. The sequence matters. You answer these questions in order and you don't start designing the facility until questions 1 through 4 are resolved. Okay. Think of product, process, and schedule design as a triangle with facilities design at the center dependent on all three. So the product designer specifies the end product, dimensions, material composition, and packaging. Process planner determines how the product will be produced, operations, equipment, and sequence. Schedule planner specifies production equipment requirements and personnel needed. Facilities planner sits at the center, depending on timely and accurate input from all three. The dependency flows in one direction. The facility planner cannot do their job until the other three have done theirs. If product design changes after the facility is built, you're back to the Ohio example from the introduction. This is not theoretical. It's one of the most expensive mistakes in manufacturing history, and it happens regularly. Each phase has defined steps and produces specific documentation. Here's the full picture. This table is the roadmap for the next two videos. Today we cover product design. Video 2 covers process design in detail in the parts and operation process charts. That's where the facility planner gets the operational data they need. Product design, influencing factors and tools. A product design a product design is influenced by eight functional areas simultaneously. Aesthetics, functions, materials, manufacturing, marketing, purchasing, industrial engineering, and quality control. No single department owns the product design. It's a cross-functional output. To ensure the design actually meets customer needs, not just engineering requirements, two tools are used. First tool, the QFD. First tool, the QFD, is an organized planning approach that takes customer needs and systematically translates them into product characteristics, process design requirements, and tolerance specifications. The classic tool is the House of Quality Matrix. Customer wants one axis, engineering characteristics on the other, with correlation cells in between. It prevents the classic failure mode where the product passes all the internal still fails in the market. Product product design produces three documents that the facility planners use directly. One is exploded One is exploded assembly drawing. This drawing shows all parts of the product in their correct relative positions, slightly separated so each component is visible. It's drawn to scale but omits specifications and dimensions. The purpose is visualization. Second is exploded part photograph. An alternative to the drawing, physical parts arranged and photographed in the correct assembly orientation. Photographs are especially useful in oral presentations and for training production staff. And for the third part, component part drawing. This is the detailed engineering drawing for each individual part. It provides part specifications, dimensions, tolerances, and material notes in sufficient detail to allow fabrication. Here's a key rule. The product design must be finalized before the facility is designed. If it isn't, the facility needs to be flexible, which significantly increases cost and reduces efficiency. Now let's talk about CAD and concurrent engineering. Two tools have transformed how product design is done in modern manufacturing. First, computer-aided design. Computer-aided design is the creation and manipulation of design prototypes on a computer to assist the design process. Instead of drafting on paper, designers build digital models. Changes that would take days on drafting boards takes only hours in computer-aided design. Their second tool is concurrent engineering, also known as simultaneous engineering. Different design stages run simultaneously rather than consecutively. In sequential engineering, you finish requirements before starting the finish design, before starting implementation, and so on. Each stage waits for the previous one in concurrent engineering. Stages overlap. Design begins before requirements are fully locked. Implementation starts while design is still running. Verification begins before implementation is complete. So, let's bring it together. In the next video, we go into process design, the make or buy decision, parts list, bills of materials, route sheets, and the assembly and operation process charts. That's where the facility planner gets the operational data that drives layout decisions you see there. Thank you for listening and have a good day.